this video helpful, please like, subscribe and press the bell icon for notifications. So guys, today we will be learning about pivots and free variables. So a pivot is a leading coefficient or a leading entry or a first non-zero entry of each row in a matrix in row echelon form, that is REF, or reduced row echelon form, that is RREF. So in row echelon form, that is REF, pivot could be 1 or any other number. Whereas in RREF, that is reduced row echelon form, pivot is always 1 and each pivot is the only non-zero entry in its column. Now let's take an example with an augmented matrix 2 minus 1 1 minus 1 1 2 minus 2 2 1 1 1 1. So its row echelon form is, that is REF, 2 minus 1 1 minus 1 0 1 minus 1 1 0 0 minus 4 0. Now the leading entry of row 1 is 2, leading entry of row 2 is 1 and leading entry of row 3 is minus 4. Therefore these are the pivots of this matrix. And we can always make pivots equal to 1 by scaling the rows. So let's scale R1 and R3. Then we will get 1 minus half plus half minus half, then 0 1 minus 1 1, then 0 0 1 0. So now the leading entries in row 1, 2 and 3 all are 1. So pivots are 1 here. Now those entries in original matrix that became pivots in row echelon form are at the position of 2, 2, 1, that is A11, A22, A33, and these are called pivot positions. And here it is A11, A22, A33. Now let's take the reduced row echelon form of A, that is 1 0 0 0 0 1 0 1 0 0 1 0, and as we can see that leading entries for row 1, 2 and 3 are 1. So these are the pivots, and pivots are the only non-zero entry in their respective columns. So we can say that all pivots are equal to 1 and all pivots are the only non-zero entry in their respective columns. Therefore, this matrix is in reduced row echelon form. Now let's take two matrices. First one is 1 4 0 0 0 1 0 0 0, and the second one is 1 0 2 3 0 0 1 0. So now in first matrix pivots are 1 and pivots are the only non-zero entries in their respective columns. So we can say that this matrix is in reduced row echelon form. Now look at the second matrix where both rows have a pivot. Therefore this matrix is in row echelon form. But this pivot is not the only non-zero entry in third column. Therefore it is not in reduced row echelon form. So for reduced row echelon form, pivot should be the only non-zero entry in its column. So pivots in row echelon form could be 1 or any other number. So if 2 minus 1, 1 minus 1, 1, 2 minus 2, 2, 1, 1, 1, 1 be original matrix and its REF is 2 minus 1, 1 minus 1, 0, 1 minus 1, 1, 0, 0 minus 4, 0. Then 2, 1 and minus 4 are the leading entries of row 1, row 2, row 3 respectively. So these entries are the leading coefficients. Therefore, 2, 1 and minus 4 are the pivots. And 2 is in first column, 1 is in second column and minus 4 is in third column. Then the columns in REF that contain them are called basic columns, and the corresponding columns in original matrix are called pivot columns. So columns in REF or RREF form are called basic columns, and the columns in original matrix are called pivot columns. So the corresponding entries in original matrix are 2, 2 and 1. Therefore, these columns are the pivot columns, and these are the pivot positions at A11, A22 and A33. Now if A be any original matrix and its REF is 1, 2, 3, 4, 5, 0, 1, 2, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0. Then 1, 1 and 1 are the leading entries for row 1, 2 and 3 respectively. So these are the pivots. So these columns are basic columns that contain pivots, and the corresponding columns of original matrix A are called pivot columns. So the columns that contain pivots are called basic columns in REF or RREF, whereas in original matrix they are called pivot columns. Now pivots when matrix is in reduced row echelon form, that is RREF. So let's take a matrix in RREF, and that is 1 0 0 2, 0 1 0 1, 0 0 1 3. So all the leading entries in row 1, 2 and 3 are 1, and these are the pivots, and these columns that contain pivots are called basic columns, or we can say, pivot column too if you want to. So when every column except the last, that is augmented column, is pivot column, then the system of linear equation has unique solution, that is we will have only one solution. So if every column other than the last augmented one is a pivot column, then we will have a unique solution, or we will have only one solution. Now let's take another matrix in RREF, and that matrix is 1 2 0 0 1 1 0 0 1 0 2 2 0 0 0 1 3 2. So the leading entries for row 1, 2 and 3 are 1 1 1. So these are the pivots, and the columns that contain them are the pivot columns. So the column 1, 3 and 4 are the pivot columns, and the column 2, 5 and 6 are non-pivot columns. So when last or the augmented column and some other columns are not pivot columns, then a system of linear equation has infinite solution. So if we have augmented and some other columns as non-pivot columns, then we will have infinitely many solutions. Now let's take one more matrix in RREF, and that matrix is 1 0 1 0 0 1 0 0 0 0 0 1. So the leading entries for row 1, row 2, row 3 are 1, and these are the pivots, and these are the columns that contain them, and these are called basic columns, or we can call them pivot columns too. And as you can see that last or augmented column is a pivot column. So when last column or the augmented column is a pivot column, then a system of linear equation has no solution. That is, system is inconsistent. Now let's talk about the free variable. So a free variable corresponds to a non-pivot column. So if a1x plus b1y plus c1z is equals to d1, and a2x plus b2y plus c2z is equals to d2 be two linear equations, then they can be written in augmented form as a1 b1 c1 d1 and a2 b2 c2 d2, and x, y, z and c correspond to column 1, 2, 3 and 4 respectively. Now if RREF of this matrix is 1 0 0 3 0 0 1 1, then leading entries for row 1 and row 2 are 1, and these are the pivots, and x, y and z correspond to column 1, column 2 and column 3 respectively, and these two columns are the pivot columns because they contain the pivot. So we can write px and pz because x corresponds to this column and z corresponds to that column, and this column is non-pivot column, and free variable correspond to this column, this non-pivot column, and that free variable is y here because y corresponds to this column. So y is free variable, so we can choose any value of y, therefore we will have infinitely many solutions, and x and y are called basic variables. So x and z are basic variables, whereas y is a free variable. So we can put any value of y here. Now let's understand this with an example where RREF of a matrix is 1 2 0 2 0 0 1 3. So the leading entries for row 1 and row 2 are 1, and these are the pivots, and X, Y and Z correspond to column 1, column 2, column 3 respectively, and these two columns are the pivot columns. And because X corresponds to column 1, so we can write PX here, and Z corresponds to column 3, so we can write PZ here. Now this is non-pivot column, so free variable correspond to this column. So Y is free here because Y correspond to this column, so we can write Fy. F is for free, Y. So Y is free variable, so we can put any value of Y. Now row 1 can be written as X plus 2Y is equals to 2, and row 2 as Z is equals to 3. Now express each basic variable in terms of free variable. So we can write X is equal to minus 2Y plus 2, and Z will remain 3. Therefore X, Y, Z is equal minus 2Y plus 2, Y and Z will always be 3. So Y could be any number. So let's put few values of Y. So when Y is equals to 0, then X, Y, Z is equal 0 plus 2, 0, 3, which will give us 2, 0, 3. And when Y is equals to 1, then X, Y, Z is equal minus 2 plus 2, 1, 3, which will give us 0, 1, 3. And when Y is equals to minus 1, then X, Y, Z is equals to minus 2 times minus 1 plus 2, minus 1, 3, and we will get 4 minus 1, 3. So we can go on and on and on to get infinite solutions. Now let's take another example where RREF of a matrix is 1 0 2 0 1 1 0 0 0, and the augmented column is 1 minus 1 0. So the leading entries for row 1 and row 2 are 1, and these are the pivots, and X, Y and Z correspond to column 1, 2 and 3 respectively, and column 1 and column 2 are the pivots column. So we can write Px because X correspond to first column and Y correspond to second column, and this column is non-pivot column, and a free variable correspond to this column, so Z is free variable here. So if Z is free variable, then we can write any value of Z. So now row 1 can be written as X plus 2Z is equals to 1, and row 2 as Y plus Z is equals to minus 1. Now express each basic variable in terms of free variable, and here basic variables are X and Y. So let's write in parametric form and take a parameter t. So Z will be t here because Z is a free variable. So now write X and Y in terms of t, and we will get X is equals to minus 2t plus 1 and Y is equals to minus t minus 1. So XYZ is equals to minus 2t plus 1 minus t and t. Now let's put few values of t, and let's take t is equals to 0 first, then XYZ is equal to 1 minus 1 0, and when t is equals to 1, then x, y, z will be 1, minus 2 and minus 1. And when t is equals to minus 1, then x, y, z is equals to minus 1, 0 and 3. And we can substitute as many values as we can to get infinite solutions. So free variables play an important role in solving a system of linear equations with infinite solutions. So if 1 0 0 1 2 0 0 0 1 0 1 0 0 0 0 0 0 1 0 0 0 0 0 0 be any matrix in RREF, then leading entries for row 1 2 3 are 1 and these are the pivots. And if x1, x2, x3, x4, x5, x6 corresponds to column 1, 2, 3, 4, 5, 6 respectively, then these three columns, which are column number 1, column number 3 and column number 6, are the pivot or basic columns. We can name them px1, px2, px6, where p stands for pivot, and the column number 2, 4 and 5 are non-pivot columns, and free variables correspond to these columns. So we can name them fx2, fx4, fx5. F is for free variable. Therefore, x2, x4, x5 are free variables and x1, x3, x6 are basic variables. So for free variables, we can put any value of x2, x4 and x5 to get infinite solutions. So in our next topic, we will be covering consistent and inconsistent system of linear equations. Thanks for watching.